Okay, so part two here in discussing coterminal angles. So hopefully this illustration made some sense about what coterminal angles are. It's one ray, right? It's one angle that has a vertex here at the origin. Okay, but I can measure that angle positively and stopping before I go around. I can measure it negatively and stopping before I go around, or I can go all the way around and then come back and stop, right? So that's the idea graphically, or using the diagram. But if you're looking for something more concrete, something that you can always use, think about it like this. Okay, take your angle theta, even this 360-degree angle. What did we say? 330 degrees. Okay, and I'm going to clean up. I'm going to clean up all this stuff here. Right, new slide. Even though I just erased something that could have been useful, right? We said this is 330 degrees all the way around like so, okay? Then we said if you go all the way around, here's how I'm going to draw this. If you went all the way around, right, and then you kept going all the way over to here, okay, you're getting very sleepy, right? That's a full 360 and then 330. So we can find a coterminal angle for anything if we add 360 degrees to it. It's that simple. So when you're asked, hey, what's a coterminal angle for 40 degrees? Well, add 360. That's one full rotation. That's 400 degrees. So 400 degrees and 40 degrees are coterminal. They're the same spot on this coordinate plane. Okay. By that same rationale, okay, if you subtract 360 degrees, so if I come all the way around to here, well, if I subtract 360 degrees, let me get a different color, from here, and I come all the way around and end up in the same spot, then that's another coterminal angle. So all we do to show that is we say you can add 360 degrees or you can subtract 360 degrees. So think of this as a quote unquote formula for finding coterminal angles. Okay. And at this point in the game, we've probably talked about radians, right? So we are going to see angles and radians that we're graphing here as well, right? And how would we adjust this formula for radians? We can add or subtract 2 pi because 2 pi is equivalent to 360. Couple of things, okay? Now, the first thing is this. 2 pi, right, is not a fraction. Many of the angles that we look at around this coordinate plane that are in radians are usually in fractions, okay? They're in terms of halves, they're in terms of thirds, they're in terms of fourths, and they're in terms of sixths. We're going to see a lot of these denominators, right? So we're going to see things, just as an example, we're going to see things like pi over 2. We're going to see things like 4 pi over 3, 3 pi over 4, 11 pi over 6. You're going to become very familiar with these angle measurements after a while. So even though we add or subtract 2 pi to this, you need to be comfortable writing 2 pi in terms of halves. Like 2 pi is 4 pi over 2, which is equivalent to what over 3, right? How would I get 2 pi? What would I need the numerator to be if I wanted this to be 2, right? 6 pi over 3. In terms of fourths, 8 pi over 4. In terms of sixths, 12 pi over 6. So even though I write this formula with 2 pi, these are the values that I'm actually going to be adding here. And you'll see what I mean with one of the examples that we're going to look at here in a second. One final note before we move on. We don't just add 360. We can add a bunch of 360s, right? What do I mean? If I have this angle, okay, let me clean this up just for a second. Okay, if I have this angle, this 330-degree angle, which we've seen how many times now, but if we have this 330-degree angle and I go once, twice, 3 times, and then I stop, I've added 363 times and ended in that position. So the way that we show that is by putting an N after this. Okay, so we're saying this angle, this 330-degree angle, for example, plus 360 times N is represented by this terminal side right here, meaning it is 330 degrees, okay, But if I add 360 degrees once, I end up here. If I add it twice, I end up here. Okay, so this n is 1 or 2 or 3 dot dot dot, right? One time around, 2 times around, 3 times around, okay, to end up in that same spot. Same thing down here for this n with the radians. Okay, let's look at some examples.